So we are going to look at the chi-squared test, which is something you're going to use a lot in AP Bio. So first off, the chi-squared test is used to determine if there is significant difference between the expected and the observed data. One of the things you're going to hear talked about is this thing called the null hypothesis. And that is when there is no statistically significant difference between expected and observed data. We can measure our data and see if there's statistical difference between the two thanks to the chi-square. And then basically with the null hypothesis, it's saying that if there's any differences are due basically to chance alone. So here is the formula, and when you look at it, you could probably freak out a little bit, but we're going to break it down. It's going to be pretty easy. So here we have the chi-squared, which is the x squared, equals, and then this, the big sort of looks like an E, is the sum of, which you might remember from math class. And on top we have the observed frequencies minus the expected frequencies squared over the expected frequencies. So once we plug it in, it's not going to be that complicated at all. So how do you use it? So first you're going to determine the null hypotheses. All frequencies are equal or specific frequencies are given already. You're going to use the formula to calculate your chi-square value, and then the O or 0 equals the number of outcomes or categories. E is equivalent to the expected, and little o is the observed. So the other thing you need to know about is the critical value and degrees of freedom. Degrees of freedom, since we're comparing outcomes, you need to have at least 2. All you do is find the degree of freedom is to take the 2 outcomes, or however many outcomes you have, and minus 1. Then you have your degree of freedom. So if we had a dice, we would have 6 possible outcomes. You minus 1, your degree of freedom would be 5. So, and you're going to have a table which is going to come up in a moment, and I'll show you that. And basically if your chi value is less than, then you're going to accept your null hypothesis, and if your chi value is higher than or greater than the critical value, you're going to reject it. Now this is going to make sense. This is the degrees of freedom over here, and then you have your critical number, and you're always going to use that middle column, the 0.05, because this just shows that we're 95% sure we are accepting or rejecting our null hypotheses. So here's a quick sample problem that we're going to go over. So you have 100 coins. You flip them all. You're expecting them to be 50 and 50, right? We have 2 outcomes, heads and tails. So you go ahead, you flip all the coins, you sort them accordingly, and you find out that the outcomes you observe, you end up with 40 heads and 60 tails. Now these numbers are completely made up. I didn't sit and flip 100 coins. I'm not expecting you to sit and flip 100 coins either. This is just for the math portion. So we're going to organize our data. The expected heads, again, we expect that we're going to have 50 heads and 50 tails. However, we observe we got 40 heads and 60 tails. So we're going to set up our equation, observed minus expected squared over expected. So we're going to set it up once for heads, which is on the left, and once for tails on the right. And then we fill in our numbers. And then you're just going to do your math. Eventually you end up with 100 over 50 and 100 over 50, which equals 200 over 50, which gives us 4.0. So here's what we're going to do with our 4.0. We get the 4.0 from our chi-square. We go back and look at the degree of freedom and the critical value to see if we're going to accept or reject our null hypotheses. So again, our degree of freedom, we had 2 possible outcomes. You minus 1, we end up with 1. So we come over here, we're looking at the 3.84. As we can see, we got above a 3.4, therefore we are going to reject our null hypothesis, which basically means that something went wrong. Maybe it was how we flipped the coins, the table the coins landed on. Maybe we had all the coins in a cup and not all of them got a fair chance to shake. There's many different possibilities. So here's a sample problem I want you to do this weekend. You buy a package of M&Ms from the factory store and find the following: 20 brown, 20 blue, 20 orange, 20 green, and 20 yellow. According to the M&M website, each package of candy should have 13 brown, 24% blue, 20% orange, 16% green, 13% red, and 14% yellow. You realize you're missing red M&Ms in your package. Is this acceptable, or did something happen in the factory during the packaging process? You're going to use the chi-square test to find out the answer. So you're going to bring your work to class on Monday and have it all laid out so we can discuss it and be ready to run your own chi-square test with M&Ms when you come to school on Monday. If you have any questions, shoot me an email. Otherwise, I will see you then.